Hello everyone. This is the second recording for uh, this problem, the emergency call dispatch problem. So we try to implement the second criteria, which is the smallest ratio first. So go to the Colab. So this is the code that we had for the first criteria. So the only thing I need to do is just copy paste this code here, and so we need to just make some modification to this code to have the second criteria. So if we look at the pseudocode that we have for the second criteria, which is the smallest ratio first, the only modification that we need is about the I star. So previously we choose the I star as the arg max of the WI. I belongs to the capital F. So we choose the call that has the highest priority, which means the highest WI. Now we are looking for a call that has the minimum ratio, and this ratio is PI, the processing time divided by WI, which is the wait. Or you can change this one to argmax of WI divided by PI. There's no difference between these two, but we are just going to follow this this line that we have at this criteria that we have at line 6. So we are looking for a call I star that it's PI divided by WI, processing time divided by wait, or the priority is the minimum. And the rest of the pseudocode is the same as what we had for the first criteria, which was the highest ratio first. So going back to the Colab, again, these are the input data that we have. Everything is the same. And here is the place that we actually try to have the I star. We choose the best call based on the criteria. So we keep the best the best I as the first element of the priority list, and then we have so instead of highest priority, I'm going to have the smallest ratio, and the smallest ratio is the processing time PI of the best I minus 1 divided by the WI, the weight of the best I minus 1. So this is the smallest ratio of that call. And then we are looking for the items. If they have ratio smaller than this is smallest, so we need to update the best I and the best ratio. So if for any item in F, the PI of that item I minus 1 divided by WI minus 1, which is the ratio of that item, is less than, instead of the highest priority, we have the smallest ratio. If there is a call in this set that its ratio is less than the smallest ratio, so we need to update the best I, and also we need to update the smallest ratio, which is going to be P sub I of I minus 1 divided by the W of that one. And here is the only change that we need to do for selecting the I star, and after that everything is the same. We need to append that item to the S, updating the solution set, updating the objective function updating the cumulative waiting time and also updating the f. So let me run this line of code again, and here is the solution. So at the beginning, the set of candidates includes all the calls 1 to 5, and the selected call is this time call number 3. And why this is call number 3 is because we have, if we do the division here, this is more than 1, this is greater than 1, this is equal to 2, this is greater than 1, and the third call ratio 4 divided by 4 is the minimum, which is equals 1. So that's why we choose this call number 3. So we have call number 3, the objective function is 0, there is no waiting time for this call, and after that the cumulative waiting time is the processing time, which equals to 4. Then the set of candidates will be 1, 2, 4, and 5. There is no 3 anymore. And which call we are going to choose? The call number 1. So again, looking at the division, this is 2, this is 1.5, this is 1 point something, but this is the smallest because the distance is just 1, and this one is greater than this one, so you can do the comparison and make sure that this is the smallest value, which belongs to the first call. 6 divided by 5 is the smallest among those 4, so we choose the selected the first call. The objective function is the waiting time 4 multiplied by the weight of this item, which is 5. 4 multiplied by 5 is